Hello guys, today I'll be covering a very interesting topic, and the topic for today is GenAI reference architecture. Because current market, a lot of applications, business is developing on the generative AI, and data platforms are generally targeted for many projects, not only for BI, but BI and AI, but also for generative AI. So I take a chance for today to discuss the Gen AI architecture, reference architecture, which can be applied to any project. And if you already are working in a project, just just stop me for a moment. Think of your architecture, and then you go through my video and just reflect that if I'm missing anything or you are missing anything. This is a good point from the architectural part. So if you can see, I will take an approach where I will take top-down approach. So I will be very high level discuss what are the key components in generative AI applications architecture, and then I will go one by one. I will detail that architecture, right? So what I meant to say that in the generative AI applications, whatever you are developing, there will be some machine learning components because you are using generative AI or classical AI. So there will be a ML kind of sub-architecture inside the bigger architecture, and there will be some non-ML architecture, which are in your business kind of applications. And then you have to store data, you relational, structure, unstructured, vector, everything. So this is the data layer, and lastly the operations, because whenever you are deploying applications, there will be some logging, monitoring. These are like CI/CD. These are kind of operations. So now I'll go to the next step to make one by one in more detail. So when I say non-ML part, these are the four key components which you can think as a part of the architecture, which is starting with the user interface, where users will interact with the business applications. The business logic will basically hold the main business requirements, right? As a backend component. Data stores are mainly, this is a business data store where we will be storing the business data as per the requirement of the business applications. And APIs are like application programming interfaces by which the application will basically internally call the services like the model and all these GenAI components. Now coming to the next level, we have a GenAI component, which is the heart of the applications for GenAI applications, starting with models. So what is going to happen now that whenever you are building an application, right, you are choosing your right model, right? You are taking OpenAI model, Llama, Mistral, Claude, right? So these are the GenAI models you are using. So this is the layer where you will be doing that. Also, if you have any classical model as a part of your application architecture, you can also integrate that as part of the model's component. Hardware infra is something like GPU, CPU, all these that compute, right, which basically allow your GenAI applications to run smoother and faster. Agents, so you can have a like a common kind of agents, right, as a part of the GenAI architecture, which is enterprise wide, right? So you can develop a say email agent, which basically will redirect to the corresponding email to different divisions in an organization, and you may have developed a common agent, GenAI agent for that, and this will be part of your application GenAI architecture, right? So basically, you may be devising some applications for HR, you are devising some applications for operations and for marketing. So all of them will be using this common GenAI agents, and for every application architecture, these agents will be called. So what is the guardrail? In GenAI applications, we know there are two things which we need to handle for the compliance perspective. One is the bias, and one is the hallucinations, right? So these are the components where you will be keeping track of if the GenAI applications which you are building, the output when there it is giving, how much bias it is having in the output data, and if it is creating a lot of hallucinations. So that kind of tracking or that kind of storing or that kind of identifications will have happen in the guardrail component. Now, next is the data components, which is obviously the heart of the GNA architectures. And I can think of these are the key four areas of data which you need to store, right? So there will be data pipelines, which will be basically bringing your raw data for training or fine tuning the GenAI models. And also, whenever you are deploying application as an inference. Whenever you are invoking the services, you are getting the data back. So that pipelines also will take the data back to your application level and then to user. Now, vector stores and graph stores are generally used for vector embedding, because whenever you are having the text data, you will be embed that data and do vector embedding and store in the vector stores. And these will be used mainly for generating the retrieval augmented generation applications, where you need your GenAI LLMs to give more accurate answer, like contextual answer. So for this, you will be exhaustively use vector stores, graph stores for semantic search kind of things. Prompt stores will be storing all your prompt templates, and then all your prompts, which can be stored for reusing inside the application as well as at the runtime and also at the development time. And memory or cache is a very important component, because most of the time, if you want to restrict your token, consumptions, so a lot of things you can keep in cache or memory, which can be used to reduce down the running cost of your GenAI application. So memory is a very important factor going to play in optimizations of GenAI application framework or architecture, where cost and time and resources are the major factor to decide a GenAI applications is running fine or not. Now, coming to the last point, which is operational components, which is pretty standard in any applications, but here a little bit difference. You will be using CI/CD pipelines to deploy your ML, non-ML, and data components, right? And then logging is required, because you will be logging the GenAI application performance and the if any error is happening. So those kind of logging will happen. And tracing of data is more like what I was discussing, like hallucination, bias data, this kind of or token, how much token you are consuming, right? So how much cost you are consuming. So this kind of trace data store you can create, where you will be continuously, when the application is running, you will be continuously having a track of those data, and using those trace data, you can generate some metrics. So you can have a metrics tables where you'll be storing those matrices, and then you will try to find how your application or GenAI application architecture is running. So, for example, you can have a bias score, you can have a hallucination score, right? You can have a token cost score, right? Which will basically, once you design your architecture and you implement and deploy into productions, right? So as an architect, you can optimize the applications and validate those architectures in a real time, right? Because for a business, it is more important that how much cost the application is taking to run, and is it breaking any compliance? Is it very biased so that the users will be impacted? So these are the parameters you can control using the operation components. Now, this is a high-level overview, and I just took all our components end to end. So, in a typical day, if you deployed a GenAI applications with this architecture, so user will hit your user interface, right? And then it will go to business logic layer, and then it will be invoking API. And at that time, if it required any reference for the business data. So it will go to the data store to fetch that, and then it will directly go for LLM models, and then through orchestration layer, it will go to LLM models, and then or the RAG databases, vector stores, right? And any common agents you have developed, and guardrails all will be stored. Guardrails will be stored, and these prompt stores will be used whenever you are using the prompt chain templates, and also you can use the prompts. And the below is already I discussed. These are the trace layer, logging layer, CI/CD layer, and metrics layer. So hope you have enjoyed the video. This is a short video, and I just want to highlight the high-level GenAI architecture. Have a good day.